Okay, welcome to section 1.7, which deals with exponents, order of operation, and averages. So what in the world is an exponent? An exponent is basically, so what is exponentiation? I guess you can also ask that following question. It's a mathematical operation that's basically repeated multiplication. So remember that multiplication could be thought of as repeated addition. That's basically what it is. What if you wanted to keep multiplying, right? So that's what exponentiation is, and there's parts to it. This is the small part is the exponent. Sometimes people call it the power, but this is also known as the base, and we'll see this again. So what does that 3 to the power 2, we say 3 to the power 2, that's how we say it. It's also known as power. We're basically saying I want to multiply 3 by itself 2 times, okay? So 3 squared would be 9. So again, parts of an exponent, what you're multiplying itself by. So if you have we'll do b to the power x, right? So the power would be x in this case, or sometimes people call this the exponent, and the base is the larger number, right? So whatever it is that you're multiplying. So some examples: 5 squared, 3 to the power 4, 10 to the power 5, and so on. That's kind of what the exponent looks like. So let's see if you can write these out and then read them and write down using symbols. So if you want to try this, go ahead and push pause now if you are in a rush. Otherwise, just listen in. So 3 squared would be 3 to the power 2, right? 3 squared. 2 to the third power, you see? And then 2 to the fifth power would be 2 to the little 5, right? To the power 5. 5 cubed, that's another one. Okay, so squared, cubed, and then we can also say to the third, fifth, fourth, and so on power, okay? So let's go ahead and see if we can solve these. So let's do another super fun example. So this would be 5 times 5, which is 25. This would be 2 cubed, which is 2 times 2 times 2, 3 times, sorry, which is 8. This one's 25, this one's 8. 1 to the power 4 is 1 multiplied by itself 4 times, well that's just equal to 1. 2 to the power 5 is, again, like you would think, 2 multiplied by itself 5 times, okay? So that would be 32. Alright, so 2 very special exponents. Ooh, what happens when the exponents are 0 or 1? Okay, so in general, if you have any number raised to the power 0, that is equal to 1. Okay, so for example, if you have 5 to the power 0, that's 1. 2 to the power 0, that's 1. Square to the power 0, that's 1. Or 1 million to the power 0, that's just going to be 1. Okay? What about when the exponent is 1? So any number raised to the power 1 is just going to equal that number again. It's kind of like how we assume there's a 1 in the coefficient. So that really doesn't do anything. It's like, hey, multiply by itself. Oh, it's only one time. It only is there once. Okay. So it would be like x to the first would be x. 3 to the first would be 3. 10 to the first power would be 10, and so on. Okay. And in the future, we're going to go through some of these more in depth, but just I wanted to kind of just talk about the fact that their exponents have properties, okay? And we're going to go over this further, but just to kind of give you a sneak peek to the future, if you have, and you might also have seen this, if you have the same base, different exponents, and you multiply those together, you can add the exponents, right? So x to the m times x to the n, it would be x to the power n plus n. And then when you're dividing same base with different exponents, you subtract top minus bottom. When you raise a power to another power, you multiply. Okay, so this one you would add. This is subtract the exponents. This is multiply. Okay, so this would be distribute, right? Distribute. When you have a product raised to an exponent, it goes to each piece of each factor in that product. Okay, and in the quotient, same thing. This is another distribution. Distribute. Okay. So yeah, so it goes to the top and the bottom. When you have a negative, it means to reciprocate or take the reciprocal of. Reciprocal. Okay. And so same here. So x over y to the negative power would be y over x to the n. And we just talked about 1 and we talked about 0 as well. Okay, so yeah, and it's pretty easy to prove these. You know, just take some examples. Let's say if you want to multiply 2 cubed times 2 squared. Well, this means that this is 2 multiplied by itself 3 times. This is 2 multiplied by itself twice. So together you're going to have 5. Okay, so that would be an example of this. An example of this one would be 2 cubed over 2 squared. 2 to the power 3 minus 1, that's just 2, 3 minus 2, that's just 2 to the first power, or just 2. Okay? And then this one would be like 3 to the power 2 raised to the power 3. We would multiply these two together, that would just be 3 to the power 6. Okay? And then this one, let's say you had, 2 times 5 raised to the power 2, and let's say you wanted to distribute it this way, you would write 2 squared times 5 squared. Okay, and then the same thing for fractions. 2/3 raised to the power 4 would be 2 to the 4th over 3 to the 4th for the division 1. Negative, so if you have 3 to the negative 1, that would be 1/3. Okay, if you have a negative number and you're talking about a fraction, so let's say you have 2/3 here raised to the power negative 3, that would be the same as 3 halves raised to the 3rd power. And then you could simplify this further using the quotient, power of a quotient property. Sorry, I didn't realize you guys couldn't see that. Which would be 3 cubed over 2 cubed. And then this one we already did. Okay, okie dokie. So that is it for very quickly laws of exponents. We're going to go over them again, like I said. But going back to where we were, order of operations. Okay, so usually people get introduced to order of operations like PEMDAS. Please excuse my dear Aunt Sally. In this case, I use GEMDAS because parentheses aren't the only grouping symbol. There's also brackets and curly braces and fractions, if you think about it. A fraction kind of, without parentheses, it just kind of groups the numerator is one group and the denominator is another group. Okay, and we usually do this in order from left to right. Okay, this is just the order of how we solve problems. So let's do some. So simplify this expression using the rule of order of operations, right? So we're using GEMDAS. So grouping symbols first, so that would be this, right? So we would write 50 minus, and then we have 17 minus 8 minus 3 is 5, okay? That would equal 50 minus 12, which is, and then this would be 38. Okay? 38. So 7 minus 4 times 7 plus 4, well, we'll do parentheses first. 3 times 11, right? 7 minus 4 is 3, 7 plus 4 is 11. That's just 33. Okay? And then the next one, we have here 6 times the quantity, and then you have 3 plus, and then you have 2, and then let's go ahead and simplify inside here. You have 5 times 3 minus 10, so 15 minus 10. And then we write everything else the same, and let's go ahead and keep simplifying. We're going to simplify this first. So that's 6 times the quantity 3 plus 2 times 5. Okay, and that's going to equal 6 times the quantity 3 plus 10, which is going to equal to 6 times 13. Okay, and that's going to be 78. Okay, so then finally this last one, okay, we have 4 times the quantity, and this is 27 minus 18, plus 5 times 48 minus 40. So this is going to be 4 times 9 plus 5 times 8, 36 plus 40, and that's going to be 76. Okay. Okie dokie. So I think that's it for 1.7. It's like a, I don't know, water or something. Homework, and go ahead and do every other odds. If you would like to get some more practice, do all evens as well. Okay? Okay, that is it for me, and I will see you either in class or the next video.